My name is Roy Corley, and this is a Team B presentation for the NUC 495 class that started in December of 2012. I'll be talking about the Fukushima Daiichi accident, some of the history of the Tokyo Electric Power Company, TEPCO for short, and also some of the history of the Fukushima Daiichi site. I'm going to talk a little bit about TEPCO's generating capacity. We'll talk about the status of the site before the earthquake and after the earthquake, some of the timeline. Also going to discuss some of the radiological effects from this accident. TEPCO was established in 1951. They started with a total operating capital of 1,460,000,000 yen. They utilized mostly hydroelectric power generation and thermoelectric power generation at the start of their business. And then in 1971, they moved on into the nuclear power generation business. They actually did that at Fukushima Daiichi site with the number 1 unit. In 1995, they surpassed a 1 billion megawatt threshold and became one of the largest nuclear power generation companies in Japan. TEPCO presently produces over 268,000 gigawatt hours per year. That was as of 2011. This is a layout of the Fukushima Daiichi site. Here you can see reactor building 1, 2, 3, and 4, and reactor building 5 and 6. Here is the emergency response center, which was manned during this accident. Here's the dry cast storage area. You see your 500 kV and 275 kV transmission lines coming into the site from the left side of the drawing here. This is the south and north breakwaters. This is actually designed to keep you from having a real turbulent flow in this area so that they can pull in their cooling water with the pump shown here at the pumping station. Prior to the earthquake, units 1 and 3 were operating, and units 4 and 6 were shut down. They were in various states of assembly or disassembly for maintenance or for refueling. The earthquake actually shut down the operating reactors. This is due to a reactor protective system function that shut it down on seismic events. And also, the earthquake damaged incoming electrical power lines, the 275 kV and 500 kV lines that I showed you earlier. They were actually damaged beyond repair and actually caused a complete loss of AC power to the site. The emergency diesel generators did start on that loss of AC power. The shut down reactors, 2 of them were being refueled and were shut down condition, cooled down with the cat heat removal systems working. Number 5 had actually been refueled and the pressure vessel reassembled and was in the process of being pressure tested, leak tested during the earthquake. Number 6 had been refueled and was depressurized, and the cat heat removal was working on it. The number 4 reactor had the fuel out in the spent fuel pool, and it was having maintenance performed on the reactor vessel shroud. The earthquake hit at about 2:46 p.m. on March 11, 2011. That's Japan Standard Time. It was a 9.0 magnitude on the Richter scale. The epicenter was about 112 miles off the coast of the Fukushima Daiichi site. After this earthquake happened, the first tsunami arrived about 41 minutes later. That tsunami was 13 feet high and was actually below the 18.7 feet design basis for the site. 8 minutes after that one, a second tsunami hit that actually wiped out the tide gauge, caused it to fail, and so there wasn't really any indication of how large this subsequent tsunamis were. There's a total of 7 tsunamis in all. We do know that one of them, due to tidal marks on the buildings and structures, was between 46 and 49 feet high. Here on the bottom you see a diagram of what we're talking about. The grade level is actually 33 feet. That's where those buildings are actually at grade. You can see 46 feet is a good bit above that. That's 13 feet higher than what the grade level was. The main control room is here. Switchgear are denoted by the crosshatch yellow areas. The emergency diesel generator room is a green crosshatch area. And you can see that the battery room has a blue vertical stripe. From this diagram, as you can see, the 13 feet height of where the motors were at for the cooling pump station was put underwater. This actually shut down and wiped out all the cooling water flow through the site. At this level, with the emergency diesel generators being in the basement along with the switchgear and the battery room, all of the switchgear, the emergency diesel generators on units 1 through 4, and the battery were wiped out on those units. Unit 5 also took on some water and lost most of its power. Unit 6 did keep one of its emergency diesel generators operating. It was an air-cooled emergency diesel generator, and that was the only power they had. Whenever the emergency diesel generator shut down, we actually had a loss of coolant, complete loss of AC power to units 1 through 5, which caused loss of reactor coolant cavity. Unit 6 had one of the air-cooled emergency diesel generators that kept operating, and it was eventually cross-connected to Unit 5, and they used that to restore the K-heat removal to those two units. There was core damage in units 1 through 3 due to the extensive length of time to get the K-heat removal back to them. Hydrogen built up in the reactor buildings due to high-temperature zircaloy corrosion, which causes hydrogen to be released. And we actually had explosions in building 1 through 4. It's believed that building 4 actually had the release that caused most of the fission products released to the atmosphere. All of this led to a permanent decommissioning of units 1 through 4 at the Fukushima Daiichi site. Some of the radiological effects of this were really extensive. Some of them are still ongoing. During the event, dose rates as high as 1,200 millirem per hour were measured 0.6 miles from units 1 through 4. That's at the boundary of the Fukushima Daiichi site. Dose rates 37 miles to the northwest were measured at 0.8 millirem per hour. That's extremely high. Being on a nuclear submarine, we didn't see that very often, even in the engine room, whenever we measured radiation levels. Soil and water samples indicated the presence of strontium, iodine, and cesium, which are some fission products which were released. This actually led to rationing and warnings against consuming food and water in the areas. On site around units 1 through 3, there was actually measured dose rates of 13 rem to over 1,000 rem per hour. All of those high levels led to radiation exposure and contamination exposure, internal and external, for workers at the site. Two of the control room operators actually exceeded 60 rem of exposure. One had 67.8 rem, one had 64.3 rem. Most of that, about 85%, was due to internal contamination. Over 100 workers received doses in excess of the allowed emergency exposure limit of 10 rem. All in all, the Fukushima Daiichi incident was a terrible catastrophe, and it's actually going to have radiological effects and mental and emotional effects for people in the area for many years to come. Thank you for your attention. These are my references. Look forward to your questions and comments.